Okay, so this one wants us to solve the equation by completing the square and then also graph it, find the vertex, and 2 additional points. Okay, so the process is doing it by completing the square, though. So we just got done graphing these by factoring. Now we want to be able to complete the square. Completing the square is sometimes something that kids don't like that much. But it's really, really a useful skill that we have to practice. So this is a context to practice it in. Okay, we've been completing the square to find the vertex. Now let's complete the square to actually solve the equation. Find the zeros is what that means. Where does it have zero height? Where's it going to cross the x-axis? So I'm actually going to do them both at the same time because it's very similar, but so I want to show the difference. Okay. To complete the square on this one, I'm going to go ahead and move this to the other side. So we have 6x squared minus 12x. Leave a space because that's where we'll complete the square at. Add 38 to this side, and we have 48. Okay, you can't have a 6 out here in the front, so I'll factor it out. So I'm dividing a 6 there, leaves us a 1x squared. Dividing that by 6 leaves 2. And this is the space where we're going to get a perfect square. So to do that, we cut that one in half, square it in. Negative 1 squared is positive 1. I added 1 to this side. I have to add 1 to this side, but it's not really 1. It's 1 times 6. So I added 6 to this side. So we'll add 6 to this side. And now factor it. So it becomes 6. X minus 1 all squared equals 54. Okay, and now I also said I wanted to do that completing the square to find the vertex also. So the vertex, instead of it being equal to 10, we would have moved this 10 over here and made it equal to y. Okay, so I'm going to start it that way. It would have been 6x squared minus 12x. Then this would have been minus 38, and it would have been equal to y. So this 10 would have come over there and made it 48. So again, I'm going to add the 38 to this side. It'll be 38 plus 10, so that y will now carry the 48. See, over here there was no y. Now we set it equal to y and moved the number over there with it. Then it's almost all the same. Factor out the 6 just like we did here. So it's x squared minus 2x, leave a space. But now it equals y plus 48, not just 48. Cut that in half, negative 1. Negative 1 squared is 1. So I added 6 to this side. I got to add 6 to this side. So it ends up to be 6x minus 1 all squared, excuse me, is y plus 54. Okay, so see, it's very similar here. This one ended up to have an answer of 54. This one ended up having a graph, so it's got x's and y's in it, but it's y plus 54. Here's where here's where it changes a little bit. This 6 now becomes like the slope almost. It's how tall this thing is. So I would multiply both sides by 1/6, and we have x minus 1 squared is 1/6 now, y plus 54. So this means the y's are 6 times taller than normal. Okay, over here, I'm going to divide both sides by 6. So when I divide that by 6 and divide that by 6, see here we get an answer. Over here we got a vertex kind of a number with a slope kind of thing. Here we're getting a number. So we have x minus 1 all squared equals 9. Okay, so look what we have in this one. This one just gave us the vertex. I could have just written it down. The vertex is at 1, negative 54, so it's really low. The next point, I would go over 1, up 1, but the y's getting multiplied by 6. I'm going to go over 1, up 6. So if I go over 1 from the x, that'll be at 2. If I go up 6 from the y, that'll be at negative 48. So that's the next point. If I go the other way, if I go left from 1, I'm at 0, and same thing, it'll be down 48. So there's the vertex, and 2 additional points came from completing the square as a graph. Finding the zeros, finding the answers. See, now it's not equal to a graph, it's equal to 9. Okay, well, I'm going to undo this hardest thing first. So the square has to be undone first. So I'm going to square root both sides. A square and a square root cancel out, leaving x minus 1. Now, a lot of times people say the square root of 9 is 3, but it's also negative 3. So we call that plus n minus 3. And then I'm going to add 1 to both sides. So I'll move that 1 over to the other side. So I have positive and negative 3 plus 1. Now I'm going to, that's two answers. I'm going to answer it like this. I'm going to cover up the negative. Positive 3 plus 1 is 4. That's one of the answers. X is 4. And the other one, now I'll cover up the negative. Negative 3 plus 1 is negative 2. So those are called the solutions or the zeros. That's at point 4, 0 and negative 2, 0. Okay. There's the solutions. There's the vertex and 2 more points. And now we just have to graph that. Okay, so 1, negative 54. That's way down here somewhere. I'll just call that 1, negative 54. 248 would be just over and up a little, over and up 6, over and up 6. I won't even try to plot those. And then 4, 0 is right there, and negative 2, 0 is right there. So if these other 2 points are way down here, you don't have to plot them. So there's our parabola, really deep and steep. Okay, so to get the solutions, I'm going to move the 24 to the other side. I think I'll get another color. So. That way we can keep it. We'll know which ones are which. So I've got 3x squared plus 12x. Now putting a negative 24 over there makes it negative 28. I'm going to factor out the 3. That's x squared. 12 divided by 3 is 4x. Okay, cut the 4 in half is positive 2. Square that. 2 squared is 4. So it looks like I added 4 times 3 over here. So I actually added 12. So I'll add 12. Complete the square now. So that's x plus 2 all squared. And then negative 28 plus 12 is negative, 16? Okay, I'm going to divide both sides by 3, so I'll divide off the 3. So I have x plus 2 all squared equals negative 16 thirds. Square root both sides. Okay, those squares cancel out, so we have x plus 2. Okay, I can take... I think I'm just going to leave it like this. I'm going to take the negative out of there. So it's plus or minus I. Remember, a square root of a negative is an imaginary number. The square root of 16 is 4, and then the square root of 3 doesn't come out of there. Now, I'm actually going to fix this a little bit because remember, we're not supposed to leave a square root like that. So I'm going to go ahead and multiply by square root of 3, square root of 3. So really I have x plus 2 equals plus or minus I, 4 times square root of 3 over square root of 3 times square root of 3 is 3. So how we usually write that is 4i. I'll do that on the next step. So there's 2 answers here. There's positive 4i square root of 3 over 3, and there's negative 4i square root of 3 over 3. So I'm going to go ahead and take this 2 and move it to the other side. So we end up with, now, also, usually you put the real number first. So negative 2 plus or minus 4i square roots of 3 over 3, like that. Those are the zeros. Okay, and you can answer it like that. You don't necessarily have to put it in point form. You can answer those as the solutions. Now, those are imaginary solutions. Imaginary solutions doesn't mean they don't exist. I'm going to show you what that means here in just a second. Let's go find the vertex and the other 2 points first. How about I take over right here? It would have all been the same right there, only now there would have been a y here. So we would have had 3x plus 2 all squared. I'm going to go ahead and just square all that out. Equals y and then that would have been minus 16. Okay, so had I done all of this up to there, and if you're not quite sure what happened there, just go ahead and start over up here. This would have been 3x squared plus 12x equals y minus 28. Then factor out the 3. Half of that is 2, squared up there is 4, added 12 there, so I add 12 there, and now we're to this. Okay, I'm going to divide both sides by 3, just like we did here, only now I need that to stay a fraction, so I'm going to think of it as I'm multiplying by 1/3. So if I multiply this side by 1/3, that's gone. Multiply this side by 1/3, and it's 1/3. So this means the y values are times 3. So here's my vertex. -2, positive 16. The next point, the 1, 1, should be over 1, but now it's 3 times as tall. So over 1 makes that -1, and then 3 units up, so it's going to go to 19. And then starting at the vertex going the other direction to -3, and then 3 up from the 16 puts that one at 19. So there's the vertex and the other 2 points. Okay, so let's see what this is going to look like as a graph. I almost need a third color here. I'll just do it in red though. Well, no, I'll do it in black. -2, 16. -2, there's 8, 9, 10, 11, 12, 13, 14, 15, 16. It starts right there. Then I need -1, 19. So here's -1, and now up 19. Well, there's 16, 17, 18, 19. And -3, 19. Okay. There's the graph. And these are the zeros. Zeros are supposed to be where it crosses the x-axis. Okay, well, parabolas don't always cross the x-axis. If you get answers that are imaginary, it means they're imaginarily crossing the x-axis. It means they're not touching the x-axis. So this answer is important for calculus, but we don't really have a picture of it over here. The picture of it, really all we have now is this is indicating that this picture is not touching the x-axis down here. So that's still considered the zeros, but the zeros are imaginary because they don't touch the x-axis. Okay, let's try that again. I have 2 more. Okay, let's see here. I'll just move this stuff over there to get it started. So really we have 4n squared plus, let's see, so there'll be a -2n coming over there. So that'll be 11n, and then -2 equals 0, because that 2 will come over as a -2. Okay, that's really what the problem is. All right, well, to complete the square, 4n squared plus 11n, that 2 needs to be on the other side, so I'll put it as a 2. I might as well do them both at the same time, because this will be 4n squared plus 11n equals y plus 2. Okay, can't have the 4, so I'm going to divide it out. 11 divided by 4. You can do that as a decimal, but I'm not going to. I'm just going to call it 11/4. So that's what it's going to be here also. N squared plus 11/4. Okay, I need to have that. Having that, I'm just going to double the denominator. It's 11/8. Okay, and now I need to square that into the whole. So this is why that's why I think fractions are easier until you get to a certain point. I mean, it's going to be 121/64. Squaring is easy, you just square both of them, but then I still have to multiply that by 4. Actually, it's gonna be 121/16. Well, sooner or later, I kind of need to know what that value is. But for now, let's try to leave all of this stuff a fraction. So If you're not sure about that, you can take out your calculator and do this. It's 121/64 times 4. So there it is as a decimal. If I hit math fraction, there it is as a fraction. So it's 121/16. Now the answer is going to be, I'm going to answer all of these. The answer key is going to be always in fractions. So let's just make that through. You have to answer this in fractions. So this is 121/16. So same thing will happen over here. This will end up being 11/8. 11 squared is 121. 8 squared is 64. 121/16 times 4 is 121/16. Okay, so here I have 4 times n or x. I just like the letter x better. X plus 11/8 all squared. And now I'm going to take my calculator and add 2 to that and see what we've got going on over here. But I want it as a fraction. So it's 153/16. Okay, I'm going to divide the 4. Divide by 4. Now dividing by 4 is same as multiplying by 1/4. So there I'm dividing by 4. So I have x plus 11/8 all squared. 153 on the top, and 16 times 4 is 64. Went back to a 64. On this side, it'll be almost the same. It'll be x plus 11/8 all squared, and then y plus 100 and, what did that turn out to be? 153/16, 2 plus that. And now I'm going to take off the 4. So I have x plus 11/8 all squared, 1/4 y plus 153/16. So here's the vertex, negative 11/8 and negative 153/16. The next point, okay, I need 1 to the right of that. So, and you could take your calculator, negative 11/8, and just add 1 to it. If you don't want to mess with the fraction, so negative 3/8. And then take negative 11/8 and subtract 1. We got to go 1 to the right and 1 to the left. That's negative 19/8. So that's 1 unit more positive, and that's 1 unit more negative. So now I've got to take this 153/16 and go up 4. So negative 153/16, add 4. It's negative 5/5, so if I fractionate that, it's negative 89/16. So see, in order to graph it, we kind of need it as a decimal anyway. It's about negative 5.5. I'm going to put that in, and that's about negative 5.5-ish. And then I need, so this will be the same, negative 89/16. Okay, so there's those 2 answers, or 3 answers. We got the vertex. Actually, where was this at about? What was 153/16? That one was about 9.5-ish. Negative. Okay, so there, I can plot those. Here are the zeros. So the zeros, I'm going to square root both sides. So I have x plus 11/8, okay, plus and minus the square root of 153. That's not a perfect square, but the square root of 64 is 8. And now I'm just going to move that to the other side. So I have x equals negative 11/8 plus or minus the square root of 153/8. That's how you answer it. Okay, fractions and square roots. Now I do kind of need to know where this is, so I need that as a decimal. You don't have, since it doesn't go any further than that, that's actually how you answer, and that counts as both answers. But if I'm going to plot it, I need to basically know where that is. So negative 11/8 plus 153, the square root of 153 divided by 8. I need to know basically where that is. That's about 0.2. And then I'm going to do the same thing on my calculator. Put a minus there. That's about negative 2.9. Just so I have a reference of where to graph them. Okay, so the zeros are at about 0.2 and negative 2, almost 3. There's the zeros. The vertex, that's the negative 1 and 3/8, so negative 1 and a little bit, and then down 9.5-ish, 8, 9.5-ish, it's right about there. And then negative 3/8 is down about 5.5-ish. That seems to fit. And negative 19/8, okay, that's about 2 and 3/8. So negative 2 and 3/8 down negative 5.5-ish, and sure enough, there it is. Okay, one more. Okay, so rewriting the question, that comes over as a minus 5x, and that's going to come over as a plus 10. So really this question is 10x squared minus 5x, and then negative 18 plus 10 is minus 8 equals 0. Or at the same time, 10x squared minus 5x minus 8 equals y. So when it equals 0, we get answers. When it equals y, we get the graph. Okay, first things first, move the 8. So I've got 10x squared minus 5x equals 8. 10x squared minus 5x equals y plus 8. Took that negative 8 and put it over there. Took that negative 8 and put it over there. Factor out the 10. 10x squared divided by 10 is x squared. 5 divided, that's going to be 5/10, or 1/2. Leave a hole equals 8. It'll be the same thing here. 10x squared minus 1/2 x, leave a hole, equals y plus 8. 1/2 cut in half. You double the denominator. That makes negative 1/4. 1/4, 1 squared is 1, 4 squared is 16, so I'm adding 1/16 into the whole. So 10 times 1/16 is 10/16. So I added 10/16 on this side, I'll add 10/16 on this side. Well, 10/16 is really 5/8. Okay, so I have 10, x minus 1/4 all squared. Okay, it's 8 and 5/8. I could probably do that without a calculator. 8 and 5/8. 8 times 8 is 64, so 69/8. That's what it'll be like over here. It will be 10x minus 1/4 all squared equals y plus 69/8. The same answer, only with a y. Okay, here we divide by 10 to get rid of it. So multiply by 1/10. So I have x minus 1/4 all squared equals 69/80. Over here, when I do the 1/10 to both sides, I have x minus 1/4 all squared, and then the 1/10 is still there. Okay, over here's the vertex. I have my vertex at 1/4 and negative 69/8. Okay, add 1. If I go 1 to the right, so if I add 4/4, I'll be at 5/4. And it's going up 10. So I need negative 69/8, add 10. 11/8. Okay, so now I need 1/4 minus 4/4. So it'll be at negative 3/4, and it'll still be up 11/8. There's the vertex, and a point to the left and a point to the right. Over here are the two zeros. I'll square root both sides. So I have x minus 1/4. Those square root and square cancels out. 69 does not have a perfect square in it, but 80 does. Let's see. On a piece of scratch paper over here, 80. Square root of 80, it certainly has an 8 in it. Is 8 times 10. So 8 is 2 times 4 times 10. So 2 times 4 times 10 is 80. This 4 can come out of there. So there's a 2 on the outside and a 20 on the inside. But the 20 has a 4 in it also. So that's 4 times 5. So another 2 can come out. So there's 4 on the outside. So it's 4 square roots of 5. Okay, so it's 4 square roots of 5. Of course, we can't have that square root of 5 on the bottom. So 69 times 5 is 345. So we end up with x minus 1/4 equals plus or minus the square root of 345 over these two multiplied together to 5. So 4 times 5 is 20. So we have x equals positive 1/4 plus or minus the square root of 345 over 20. Okay, those are the zeros. I need to see about where that is. So 1/4 plus the square root of 345 over, I gotta close the square root on this, square root of 345 over 20. That's approximately 1.2. And then I'll do it again with a subtraction. 1/4 subtract the square root of 345 over 20. Oops, I forgot to change it to minus. Subtract, it's approximately negative 0.7. Okay, so here's the vertex, 1/4, that's down 8 and 5/8, so over a fourth down 8 and 5/8 is down here. 1 1/4 down a little over 1, so 1 1/4 down a little over 1, and negative 3/4 down a little over 1 is right there. That's those 2 points. And then I need a zeros at 0.2. And negative 0.7. Okay. Oh, 1.2, as I say, something is definitely wrong. 1.2 and 0.7. There. Otherwise, it wasn't looking like a parabola. And there we have the graph, the zeros, the vertex, and 2 additional points. Okay, there you go.